take a look at this. This is an algebra problem, but I would like to teach calculus process, okay? We have two boats. One boat is heading north and the other one is heading east, okay? So something that's the boat that is northward, 20 kilometers per hour. Well, that's really slow now, isn't it? Does anybody know how fast that is in miles per hour about? It's like 15 miles per hour. Like, dang, that's slow. But it's a boat, okay? Boats are pretty slow. And the other one, eastward, 30 kilometers per hour. That's about 20 miles per hour. I have an animation. Okay, see, this is the port, and those two dots represent the boats. So, see, the distance between these two boats will increase like this. You know what I'm saying? So one is going 20, and the other was going 6. Let's say that's 1 hour later, and 2 hours later, it's going to be like this. So as you can see, you should be able to animate your picture in your head, right? So you see this distance between two boats increase, right, over time. And the question is, how fast is it increasing at 2 o'clock, 2 hours later? Because the boats departed at noon. Okay, let's try to solve this thing. So I'll copy this thing. Let's just copy that much. Okay, there, too big. Make it smaller. And bring it back about here. Okay. Speed here, this way, there's a speed going this way. This is boat, let's say sub E, okay? And that speed is 30 kilometers per hour. And the other boat is moving that way. And let's say this boat sub N, and that speed is 20 kilometers per hour. Okay, now, do you guys remember D is equal to RT? What is the meaning of that confused facial expression? Like, this is algebra 1 problem. D is equal to, I used the, okay, our term, physics term, X is equal to VT. You feel better now? Yeah, of course, right? Oh, yeah, so pardon me for throwing algebra terms, like, how dare you insult me like that, right? Okay. So this is 30T. So obviously, by looking at it, right? D is equal to RT. Can we get the equation northward then? The Y, we'll call this Y. Y is equal to 20T. You with me? Okay, we'll call this thing is Z. Okay, and we want to see the rate of that thing increasing, don't we? So Pythagorean theorem should tell you that Z is equal to square root of x squared plus y squared a. Too much algebra? Too much geometry? Okay, so that is equal to square root of 30t squared plus 20t squared. Say yes. Okay. Is it equal to 10 square root 13t? Too much algebra now, right? You want me to teach you a little trick how to do that fast? Yeah, wouldn't you love to know that trick, right? Yeah, it's not like I didn't really work that out in my head. Here's the trick. Let me draw a tiny little triangle. Okay, let's say this side is 2 and this side is 3. Can you do this one in your head? Is it square root 13? 3 squared plus 4 squared is 13, right? Now, say this triangle, well, this thingy, if there's a triangle, 30 and 20 instead of 3 and 2, is this thing exactly 10 times bigger than this one? They are similar triangles, therefore 10 times bigger than that. You get it? 10t times bigger, if you will. How about that, eh? That was a neat trick now, wasn't it? You don't get it? Or whatever, okay? So, wow, then the rate must be this, right? We can take a derivative, with, although this is not a calculus problem, dz over dt, here is then 10 root 3, and 10 root 13 kilometers per hour. So this thing increases at 10 root 13 kilometers per hour. How about that? You with me? Okay. Now we'll assume, for the calculus way, we'll assume that we don't have enough algebra to figure these functions out. Because typically in this problem called related rates, functions are not given to you. You still have to find the relationship between the derivatives of these. Okay? So now let's redo the whole thing. You find the relationship. This, let's call it x, y, and z. So find the relationship between your variables. So we have z squared is equal to x squared plus y squared. So far so good. I mean, we could have used this relationship too, but I don't want to take a derivative of square root. Okay? Then at the moment, it looks like multivariable calculus now, doesn't it? Z is equal to, whoa, my God. But they are not independent variables. See, x is a function of t, y is a function of t, and z is a function of t. You get it? So there's only one independent variable, and that is t. And that's not shown right now. Okay? Now, we take implicit derivative on both sides. Do you still remember implicit derivative? We used to put, not that one, d over dx, right? But now we put, since our variable, independent variable is t, we put d over dt now. With me? Then this thing will become 2z, and then chain rule. Remember chain rule? dz over dt, eh? And the other one, this one used to become dx, and that's it, dx over dx. But now this one has a chain rule, because x is function of t after all, right? And plus 2y and dy over dt. Good? Now we are trying to solve for dz over dt. That's our answer that we are looking for. You get it? Okay, so let's solve for dz over dt. So my dz over dt is equal to 1 over z and then x dx over dt plus y dy over dt. Too much algebra? You got this? Okay, then now we have a calculator ready for them. This is a lot longer than previous case, but we are learning the process here, the calculus way, okay? What's x? Let's calculate x. If the rate of this thing is at 30 kilometers per hour, in 2 hours, this will be 40, 30, 40, 60 kilometers. Good? And then both upward moves at 20 kilometers in an hour. So in 2 hours, this will be 40 kilometers. So far with me? So we plug those in. So we have 60 here, and plus we have 40 here. So far with me? Can we calculate the rate? What is dx over dt now? Well, that's given to you is this, isn't it? dx over dt. I mean, after all, that's how we build this function, right? So that one is 30 here. And then, guess what the dy over dt is? It's this speed. Both going northward. So plug in 20 here. So far, so good. Now we have to calculate z. Well, once again, this triangle is now exactly 20 times bigger than this one, and they are similar triangles, aren't they? So this is 20 root 13a. And plug it in here. Can somebody compute this to verify we get exactly the same thing? Okay. I'm pretty sure they give you the same thing, right? Might have to rationalize the denominator a little bit, but other than that. Good. Okay, are you ready for calculus problem now? I mean, that was not really calculus. It was learning the process now. So let's look at the calculus problem, test-worthy problem. This problem was on my very AP exam in high school. I still remember it to this day. I still remember nailing it to this day. Okay, let's read this thing. We have a huge conical tank, 10 feet deep, and water is pouring in, and this surface will rise then, huh? Can you animate that? I have a question right now. As the surface rises, the speed of this surface rising, does it A, speed up, B, slow down, or C, remain constant rate? Answer that question. We should be able to predict this. Feel free to use your microphone.
Slow down.
Why does it slow down?
Because the surface area on each level is increasing.
See? You have to fill more volume with a constant rate of water. You know what I'm saying? So we expect this to slow down, meaning our answer will depend on the amount of water or height of this thing. You know what I'm saying? Okay, that's a good place to start now, isn't it? So let's start. I mean, where do we even start when we encounter a word problem like this? Well, volume formula would be nice, right? What is the volume formula of a cone? Hopefully you all know this, right? Okay, having said that, now when we say the volume like this, it's a volume of water, not the volume of a tank. Volume of the tank doesn't change, okay? So what we are saying is this is R right here, and this is H right there. You get it? Okay, and V is a function of T, R is a function of T, H is a function of T. So this is not a multivariable function. We can just take a derivative with a product rule and it'll work. However, remember that trick? Whenever we can substitute one of the variable out, let's say we switch R out in terms of H, that problem becomes that much easier because we can avoid the product rule, right? Is there a relationship between R and H? Yeah, sure there is right here. See that? You see the similar triangles? So we have R to H is equal to 5 to 10, isn't it? And that gives you R is equal to 1/2 H. Oh, that'll make our problem so much easier. Now we shove it in here, okay? So our volume will be pi over 12 H cubed. Too much algebra? You with me? Now take a derivative with respect to t. So dv over dt is equal to pi over 4 h squared dh over dt. You with me? This is almost like differentials from previous section now, isn't it? If you remove this t, dt here, then dv and then dh. You know what I'm saying? But now we are talking about over a certain time unit. So it becomes a speed. Now, what is known and what is unknown? We know what pi is. Do we know what h is? Yeah, right there. It's given to you. That's h. Okay. Do we know what dh dt is? That's what we are trying to look for. That's our answer. So this is our guy. You know what I'm saying? Speed of the water level rising. Well then, do we know what dVdt is? Can you decode this thing out? The units are the key here. That's volume. This is still division. Volume divided by time. Do you see the volume divided by time unit right there? This is your dV. Oh, that was nice. This is your dV over dt. You get it? That thing. Do we plug in these numbers now to solve for dH over dt? No, don't you dare. Calculator ready form. Do you remember calculator ready form? No. No numerical equations. I need you to do this. I need to see this part. This is 4 over pi h squared dV dt. This is like 90% of the problem right there. Plugging in is like 1%. I mean 1%, 10%. Now plug in these values. So h is 6 and dV dt is 9. And then you get 1 over pi, right? Too much algebra? So in this problem, we have this little dinghy boat pulled up by a rope from the top of the dock, right? So that dinghy is moving this way, right? But think of it as a triangle changing the shape. This side is being decreasing and this side is decreasing. You get it? And this side remains constant. Okay, now, so whose question is this? Did you want A as well or just a B?
Just the B is okay.
Just B? Does anybody want A? Okay, just B it is. So let's look at triangle here, right? And we are given this thingy, this 2. Right? That has to be dL over dt, though I call this side L, right? And this side is S, okay? That's 2 feet per second. Okay, now I can use sine, which is x over L, but then you got 2 different variables, right? And theta, or I can use cosine, which is, oh, that's nice. And I can use tangent. The reason I don't want to, okay, as you can see, sine is the worst choice right here, isn't it? You know what I'm saying? Okay, sine is the worst choice because you got 2 different variables. If you use tangent, it depends on your x dx dt value, right? You calculate it from part A. I usually want to avoid such thing because in case I screwed up A, I don't want B to go as well. So I want to decouple these things as much as possible. So I'm going with cosine, okay? So let's see, B cosine theta is equal to 6 over L. Better way of writing that should be secant theta is equal to L over 6. Do you see that? So that the right-hand side at least is nice. Okay, now let's take a derivative. So derivative of secant is, somebody tell me? I'll do the right-hand side in the meanwhile. You guys have what derivative of secant is?
A secant theta,
Tangent theta, and also
a derivative of theta.
d theta dt. Yeah, that's the one we are looking for. So if you forget that, then we have nothing, right? So solving for the theta over dt is, so we have cosine theta. Oh, let me put it this way, 1 over 6, and then cosine theta, cotangent theta, and then dl over dt. So far, so good. Now, and let's plug in these values. How do we know what cosine theta is? Well, that side is 10, this side is 6. Does that tell you this side is 8? So this is 3, 4, 5 triangle, isn't it? So we have 1/6, and cosine happens to be 3/5. And cotangent happens to be this side over that side. Oh no, the other way, this side over that side, so 3/4. Are you getting this? And dl dt from here is 2. You get it? And if we do all of that, you're supposed to get -3/28. And then unit is a fictitious unit, but like engineers, radians per second. How about that? You all with me? Any more questions? Okay, let's move down and let's do a race car. Okay, so race cars is moving away, and do you guys ever watch like NASCAR in ESPN? Okay, now we'll have to leave it to your imagination. There's a camera following this lead car, let's say, and then it passes by, and then camera has to rotate. You know what I'm saying? And then you can imagine camera is rotating fastest right here on this line, and then it's like slower out here fast, and then slow. You know what I'm saying? Okay, so that's what's going on. Okay, but we can still think of it as this triangle changing the shape, and the only side that changes is this, and this side remains constant. You know what I'm saying? Okay, so I'm gonna call this side X, like that. Okay, is tangent good one to use, right? Because we don't want to calculate this side, right? So let's use tangent. Tangent theta is equal to X over 132. How about that? Good. Then we can calculate the derivative. So we have secant theta, secant squared theta, the theta over dt is equal to 1 over 132 dx over dt. Eh? You with me? And then dx over dt is given by the speed of the car. Eh? Say yes. Okay, now, well, the theta over dt then is equal to cosine theta over 132 dx over dt. Eh? Are you with me? Okay, in order to figure out the cosine, we have to calculate this length, right? And when x is equal to, what is x is equal to? Oh, in front. So when x is equal to 0, right? Oh, this problem is truly insulting. So when this x is equal to 0, theta is equal to 0, so you put 1 here. You know what I'm saying? So you get 1 over 132 times dx over dt, which is 264 feet per second. And that should be 2 radians per second. Now, here's a little thing that I forgot. And the little thing is this x, the way it's thrown, is reducing, right? It's decreasing. So technically, we have to put negative sign here and negative sign here. But then it's a context thing. Do you really want to put negative sign or like moving? You know what I'm saying? So that theta, the way it's thrown is decreasing. So if you want to put it, I mean, you can put it, but it's a judgment call. Or you can just, you remember like in previous math classes, you have to give a complete sentence answer. Yeah, I never require such a thing because my English skill, as you will find out from second period video, my English skills, they really suck. So I can't really grade your complete sentences, so say, whatever. I'm a recovering ESL, as you say it. Okay, how about that? then you're wondering, what is that stuff in Dropbox note, right? Right. The Dropbox note, I thought I felt so insulted by this problem. Let's just find out at any x, in terms of x, not just x is equal to 0, but at any x. How about that? Okay, so I'm going to revise the problem at any x value. Then it's just this. The theta over dt is equal to, all we have to do is just figure out what cosine is, right? And cosine is this side over that side. And this side happens to be square root of x squared plus 132 squared. You know what I'm saying? Which actually, I hate numbers, so I'm going to call this S. So we can actually have a value. Cosine square is 1 over x squared plus, cosine, s over x squared plus s squared. And then we can have dx over dt, which is, what was it? 264. So you can do it this way. Let me put 264. Yeah, 264. So this thing simplifies to 2. S over x squared plus s squared. How about that? So for any x value, this thing will give you the answer, negative sign. And for example, when x is equal to 0, this thing reduces to 1, so we get our previous answer back. How's that? So that's what I have in Dropbox note, because I was so insulted by this little problem. Any question before we move on? Okay, let's move on. Speed trap. So, have you ever driven to Bakersfield, San Francisco, that area, on that Interstate 5 highway? That endless plain with a lot of cows, and this is flat. And then you get it's so boring, you tend to fall asleep. But the road is so straight, if you fall asleep for about a minute or two and you wake up and you're still on the road, that kind of freeway. And I used to speed. I really used to speed because it was so boring. I wanted to get it over with. So it's like, okay, I was young and reckless and stupid in college days, so I used to go really fast. But then there's a sign saying speed controlled by aircraft. And they actually do give you tickets. It's not like airplanes can come down and pull you over, but they radio the ground patrol units. And then by the time you come over, and then they pull you over, and then they give you a ticket, okay? I've seen TV documentaries on it, so they are not lying. So how do they then measure the distance, okay? I'm gonna draw the picture, triangle, of course. So situation is this. Okay, so airplane is going this way, and with a certain speed, I'm gonna call, that's nice. I'm gonna call that dp dt for the plane, right? And that's given to you by, what do they give you? Constant rate of, so this is 120. You know what I'm saying? Okay, and there's a car moving this way, and that is what I'm calling dx dt. Okay, that you don't know. That's what we're trying to figure out. And this is 3 miles high. Okay, and I'm gonna call this side x. This is a picture. You know what I'm saying? Say yes. So this triangle is reducing in its area. This length is reducing. This length is reducing, and this thing remains at constant. So I need another variable. Let's just call that S. Okay, and then with an S, there's a ds over dt. What is ds over dt? And I think that's what this is. You know what I'm saying? 160. You follow? Do you follow? Wait, no. Decreasing. What are they saying? Line up for the plane to the car is 5. Do you read this thing to be 160? Or do we have to add something else to it? I think it's 160, right? But I'm going to put negative sign, okay? So far so good? Because it's decreasing. Okay, let's set it up. So the relationship between these variables happens to be x squared plus 3 squared is equal to s squared, eh? Pythagorean theorem, too much geometry? Y'all with me? Differentiate, so we have 2x dx dt, which is our guy, 3 squared dies, is equal to 2s ds dt. You with me? So dx dt happens to be, and then s over x ds dt. So far with me? Let's substitute. So x happens to be, the car is 5 miles. I think this is 5 at the moment, isn't it? Okay.
Yes, yes.
So this is 5. That tells you this is 4, right? 3, 4, 5 triangle one more time. This is 4. SDT to be negative 160. So far so good. And then, to your surprise, this gives you negative 200 miles per hour. And this is what students write down. Okay, 200 miles per hour, right? Do you see something's wrong with it? 200 miles per hour is fast. It's really, really, really fast. I mean, this is faster than, okay, this is about as fast as a NASCAR, maybe faster. Most of your cars cannot go this fast, number one. Even if you have a car that can go this fast, there's a good chance you'll be airborne with this kind of speed. If you screw up just a little bit, your car will float because the entire car acts like a wing at this kind of speed. That's why race cars have this thing, wings on its like spoilers to press it down. But if it turns sideways just a little bit, it flips in the air and tumbles it several times like a leaf. You know what I'm saying? There's no way. Most cars are not even capable of going this fast. So what's wrong with this picture? Somebody explain to me, because once you write them, don't just plug it in mechanically like a robot and then write down, yeah, that's the, you have to have a feel for it. This cannot be right. Right? I was reckless and crazy and stupid, but I didn't have a car like this. I mean, even you have Lamborghinis or Ferraris, I don't think they can achieve this kind of speed. Tesla? Nah. So somebody reconcile this. I didn't screw up.
200 is relative to the.
Yeah, see, from this plane, so this x is reducing because the plane is moving this way by 120 miles per hour already, and the car's moving at some unknown speed, and that's what this x is being reduced to. But that's not the ground speed now, is it? You get it? This is relative to plane. So the ground speed do I have to explain it, or can you easily say that it's 80? Right? You have to compensate for the speed of the plane. And then 120 is a regular propeller plane, but that's really, really slow for a plane. I mean, I don't think these mathematicians knew what they were doing when they wrote this question, because that's a really slow plane. I mean, I'm surprised that it doesn't fall out of the air, because my car can go that fast. Any questions before we move on? Okay. Now, okay, two guys are walking at the right angle. And, okay, let me draw the picture for you. So two guys are walking at the right angle. There is a picture provided, but hey, this is faster, okay? So I'm gonna call this thing X and this thing Y, okay? So dx, dy, dt, I'm gonna move this thing a little bit. Dy, dt is going this way, eh? And that's negative, so that's -2. Don't have enough space. Uh-oh, my computer's frozen. Okay, -2 meters per second. Doesn't want to write anything. No. Okay, meters per second. Good, because that distance is decreasing. And then dx dt here, and that direction is this way. So it's increasing, so we'll put 1, positive 1. So first, so good? Say yes. And this angle is theta. And then they want, how fast is that angle changing, right? Okay, well, this time we are forced to use tangent. So let's say tangent theta is equal to y over x. So far with me? And the reason I want to use tangent is because this side, we can calculate it, but this side happens to be square root of x squared plus y squared, and that I really don't want to differentiate that hot mess. You know what I'm saying? Okay, so differentiate, so we have secant squared theta, the theta over dt is equal to u. Suck it up and do it, quotient rule. So we have dy over dt x minus y dx over dt. You with me? I mean, it's terrible, but it's not that terrible. Okay, so the theta over dt is equal to, let's say, cosine squared theta times that mess. You with me? Okay, what's cosine squared? Cosine squared is this side over that side now, isn't it? So substitute that in, so we have x squared over x squared plus y squared. Oh my God, I'm getting tired of writing this. And they cancel. So we have dy over dt. Maybe I should start using prime notation. I mean, I generally try to avoid it, but in this case, it's just too much writing. Good. Let's substitute everything in. So what is the dimension? So x is So this is 1, so dx dt is 1. And then this is -2 right here. And then when A is 10 meters away, so this is 10. And B is 20 meters away, so this is 20. Okay, substitute all of that in, and I'm just going to copy it from the notes. It'll be this. And that unit, remember, is radians per second. And y'all know how to convert radians to degrees? You multiply 180 over pi. Right? So this becomes about -6 degrees per second. How about that? The guy is walking and the light shines on him from behind, and this part is the shadow, right? So do you see that this triangle and this triangle are similar triangles, eh? Okay, and this is what I'm calling y, and let's just call this thing x for now, right? So the guy is 6 foot tall, and that doesn't change. Hopefully you don't shrink while you're walking. So we have x over 6 is proportional to, so I'm doing this side to that side, and then this side to that entire side, eh? So we have x plus y to 16. So far with me? I mean, this is really an algebra 1 problem, not even calculus, because we can just do it with algebra 1 skills. We can take a derivative on both sides, but what happens if we just cross multiply, right? Then I will have 16x is equal to 6x plus 6y. So I have 10x is equal to 6y. Take a derivative on both sides now. Or y is equal to, because we are trying to see, what are we trying to see? Dx over dt, right? How fast is this changing? So I'm going to solve it for x. So x is equal to 3 over 5y. And y is the guy's walking speed, isn't it? Because this distance is increasing and is given by 5 feet per second. So then take a derivative now. But you can already see the ratio. So this is 3/5 of dy over dt. How about that? Now we have to be a little bit careful here, right? Because what is dy over dt? He's walking at the rate towards the street light. He's walking this direction. So this we have to plug in -5, eh? Do you see that? If he's walking away from it, then this length grows and the shadow will grow as well. But he's walking towards it, so shadow will decrease. You know what I'm saying? So that'll give you -3 feet per second. And I think this answers one of your questions, right? Leave it as -3. That means it's shrinking. Like students, for some reason, do not like negative sign, and they have to take it away and lose points. Don't do it. I do take points. Okay, how about that? Any question on this? Okay, then we'll do number 30. Number 30, the ball dropped, right? And then, so as the ball is dropping, the shadow will move towards that point too. Correct? Okay, we'll try to have this thing. So this S is the position. S is this length is S that they. Let me zoom in a little bit. This picture is. S is this length. You know what I'm saying? And that S is given by 16t squared, right? Do you remember when I was deriving kinematics equation, it was like 1/2 gt squared? Negative? Well, if you're thinking this is a origin and then it's coming down, so it's negative. But if this is your 0 and then positive direction is this, right? Anyway, and g is 32 in feet per second square, so this becomes 16. That's what that is, but they give it to you here, so you don't have to worry about it too much. Okay, now, then what is the question asking? How fast is the ball shadow moving? Okay, let's just do similar thing here. Okay. We have this triangle right here, right? So I'm going to call this side x like this, and then I'm going to call this side y. Okay, as you can see, y is not a true independent variable. We can actually substitute y in terms of this expression. You know what I'm saying? Okay, and then we have another triangle that we can draw here. Right, and this distance is 30 feet given by the problem. So we have once again similar triangles, eh? Let's say yes. So let's say y to x is proportional to s to 30. You with me so far? Say yes.
Yeah.
Okay, but then y, x, s, we have 3 different variables, and that's not nice. We like it to reduce down to true. But what is y equal to? Y is equal to this entire height minus s, isn't it? And this entire thing is 50, right? Okay, let's say y is equal to 50 minus x over x is equal to s over 30. Okay, now at this point, we don't even have to keep x. X, did I say x? S. Okay, we don't even have to keep s because we have it in terms of t, so we can just substitute the whole thing out. Your choice. How do you want to do this? You want to keep it like this and want to see ds dt, or do you want to substitute it out? Who's the owner of this question? I will let he or she decide. Let him or her. Wait, I will let him. God, English is such a. Okay, whichever, right? I think correct grammar is let him or her decide, right?
Yeah, I think so.
I can't believe I'm recording this, but hey, I majored in math for a reason, because my English skills sucks. Okay, who's the owner of this problem?
Me. Can we just keep it as
Okay, keep it, it is. Okay, yeah, it really doesn't matter, but we still like to simplify it a little bit, so let's cross multiply. So we'll have 150, oh no, 1500, pardon me, minus 30s is equal to, yeah, about that, right? Let's not keep it. Do you know why I don't want to keep it? Because, oh, no, it's okay. Yeah, I don't want to keep it. The reason I don't want to keep it is a product rule, and it complicates our lives. You know what I'm saying? We'll see. Divide both sides by s. So at least x is equal to. So we have 1500 over s minus 30. You know what I'm saying? We can keep it as you wish, because like doing the same thing over and over is boring. Let me change that to 1500 s to the negative 1 power. How's that? Take a derivative on both sides. So this is dx dt, which is our guy. And this will be negative 1500 s to negative 2, then ds dt. And then 30 dies. So far, so good? Say yes. So all we have to do is then calculate s as well as the SDT, right? So S here is 16t squared, and the SDT, this is not what I did in the Dropbox note, but hey, 32t. You know what I'm saying? Okay, at what time are we trying to measure this? Half a second later, right? So let's substitute half a second later. So at t is equal to 1/2, S becomes 1/2 here, it becomes 4, 8. And then the SDT becomes 16. You with me? Then we plug those in. And what we have here is, I don't want to do this anymore. What is 1500 divided by 16? Somebody tell me. Somebody punch the calculator. Oh, actually, no, never mind. They cancel, right? 16s cancel. That's great. And 1500 feet per second squared. How about that? Oh, that worked out nicely. I think it's designed by the problem. You get it? Any questions? Okay, let me move down to the next problem, which is very similar to my example on my AP test. Okay, so we want to do part B. Does anybody want part A? Nay? Okay. So we have a rate. This is dV dt, isn't it? This is what we call dV dt. And depending on whether to put it as a negative or positive, really depends. But in this case, the coffee is dripping down here, right? And that is dV dt. So the volume of this thing is decreasing now, isn't it? So this needs to be negative 10 cubic inches per minute. You know what I'm saying? And as far as the spot is concerned, that volume is increasing, so you put it as a positive, but for the cone, it's decreasing. You know what I'm saying? And that's kind of all we need. After that, it's a downhill, so let's say part B. Here is, we have 1/3 r squared h. Now, let's just do the ratio here. Let's just look at this. Radius to the height, right? Is that ratio 1 to 2? Because this is 3 to 6, eh? So we can say radius to the height is equal to 1 to 2. So radius is equal to 1/2 h. And let's, oh my God, I did not put v. So English is not only thing that I suck at, huh? Okay. So let's substitute. So that b, plug in 1/2 h, becomes pi over 12 h cubed. With me? Now take a derivative with respect to t on both sides. So we have pi over 4 h squared dh dt. Now we want dh dt because dv dt is given. So dh dt, and you have to put it into this form, calculator ready form, and then dv dt. Okay, let's plug it in. So we have 4 over pi, and when this thing is 5 inches deep, right? Where is it? Yeah, here. This is our h, right? So we put 5 squared here, and the rate is negative 10. Good. And somebody tell me what this thing becomes? is it 8 over 25 pi? Am I right?
8 over 5 pi.
8 over 5 pi. Negative, right? Leave it as a negative. And then inches per second. How about that? So instead of conical tank, like an example here, we have this hemispherical reservoir. Okay, since I hate numbers, I'm going to call this thing R. Okay, R is 13. It's constant. It's a number. I know mathematicians who hate numbers, right? That's actually very common. Most mathematicians do not like numbers. Okay, they like symbols. Math is not study of numbers. Okay, and they insult us by giving us a volume, right? So A, this is part A. We just use this volume is equal to pi over 3, and then we have y squared and 3 r minus y. 8, and r is 13. 8. Okay, now, since I hate product rule, I'm going to distribute y squared. So we have 3r y squared minus y cubed. So far with me? Now I take a derivative with respect to t. Then what we're going to have is pi over 3. My computer's frozen. Uh-oh. Okay, it's working now. Pi over 3, and this becomes 6ry. Why aren't you doing product rule? Why am I not doing product rule with r and y? Feel free to use your microphone.
R is a constant.
R is constant, is 13, you get it? I mean, you could have substituted 13, but like 3 times 13, 13. You see why mathematicians don't like, and then I have to take a derivative. You know what I'm saying? R is 13, is constant, okay? Minus 3y squared. And I am not forgetting chain rule. I'm just common factoring it and putting it here. How about that? So this will give you dy dt. This will give you dy dt. You get it? So common factor dy dt. And we want dy dt, right? So that dy dt is equal to dv dt divided by this thingy. Let me simplify 3. So we have 2ry minus y squared. How about that? Happy? Okay, that's part A. Part B. We have to find the relationship between radius and y. Okay, so this is part B. Okay, Pythagorean theorem will work. So this is r minus y now, isn't it? That much, 13 minus y. So what we have is r squared is equal to capital R minus y squared. Let me put it this way. Plus r minus y squared is equal to 13 squared. How about that? I mean, you can send it over and take a square root, then you get this, but no. We're just going to take a derivative of this thing. Good? So that's B. This is C now. You could have multiplied this out and simplify it, or you can just take a derivative. Let's just take a derivative, shall we? And see what happens. Okay, if we just take a derivative, we get 2r dr dt plus 2r minus y to the first power and negative dy dta. Do you see that? Chain rule, negative sign here. And this is not 2r, it dies, it's a constant. You get it? You with me? And we are solving for dr dt now, aren't we? So dr dt is equal to putting it on the other side. So we have r minus y dy dt. Let's do it this way, and then r and then dy dt. You get it? Question? Too much algebra? And then I'm pretty sure you can manage to plug in numbers yourselves, right? Okay, moving on. Let's do this problem. Sliding ladder. Okay, so ladder is sliding down. Does anybody want A or B? Because originally question was the 19C. Does anybody want A or B? Okay, then just C it is, right? Okay, this is why diagram is like, if you draw it like this, it's better. Okay, X, Y both change, right? And theta changes, right? If those of you who like to complicate your lives, you could have done it this way. Tangent theta is equal to y over x, right? And quotient rule here, take a derivative with respect to t. That works, but like, why would you want to do such a thing? You know what I'm saying? Okay, let's see. The base is moving, so this is dx dt, isn't it? This is dx dt. You realize that? So forget this. I'm doing cosine theta. Why is that? Because cosine theta is x over, this time I'll use 13 is simply enough. 13, huh? 13. You see, we don't have to do quotient rule, eh? Now, take a derivative, so negative sine theta and the chain rule is equal to 1 over 13 dx dt. You get it? Say yes.
Yes.
Okay, now, then put it onto the other side then. Okay. So d theta dt is equal to, is that cosecant? Negative? Cosecant theta over 13, or 1 over sine, whatever, and dx dt. Okay, I'm gonna plug it in for you. Okay, so what is cosecant u? 1 over 13 is easy, but what is cosecant? Well, we get it from the triangle. At the moment, theta is 12, right? So this is 12. That makes this thing 5a and 13. Pythagorean theorem, too much geometry. So cosecant is this over this, isn't it? So we have 13 over 5, and dx dt is 5. You get it? And you get -1. And what's the unit? Radians per second. Radian is really a fictitious unit. All of this, if you kept the units and cancels out, is other than per second. But engineers invented this, radians per second. Good. Okay, questions before I move on to the next one?
Is there a reason you started with cosine rather than sine, or it does not matter which one you start with?
It doesn't matter too much, but what is given is dx dt instead of dy dt, right? So, but we have done a and b, so you know dy dt too, so you can recycle that. But whenever I have a choice, I always go back to the given one. In case I messed up, a or b, I don't want my C to be influenced by that wrong answer. So I always choose the one that is given by the problem for the partial credits. So that way, even if I totally did a brain fart in earlier problem, I still get my C correct. You know what I'm saying? So I want to make these ABC subparts as much independent as possible. Sometimes you cannot help it. It depends on the previous answer, but try to decouple these things as much as you can. That way you get more partial credit. Good?
Thank you.
Any more question? Okay, then we'll go to this. Okay, Did I tell you why this formula is the way it is? You want me to quickly derive it for you? Let's derive it, right? I think I explained to second period, but not to this period. So suppose we have a triangle like this. Okay. Now let's say this side is A and this side is B, and there's a theta right here. Good. And then this is H. So area of the triangle is 1/2 base times side A. But then do you see this H is A sine theta A? And substitute. So we have 1/2 AB sine theta. You get it? Why memorize it? I mean, it was in your pre-calc book, but why memorize it when you can just figure it out each time that fast, right? Okay, now we're going to take a derivative of this. So dA over dt. You three-way product rule, right? I mean, there's a formula, but you know how I feel about formula, right? This is my thinking. You can actually do this each time with ease. This is U and this is V. Let's just think like that. Okay? So we have a U prime V. Let's just do that part. So leave it. That's U prime V. Don't write U prime because I'm going to erase it and do that part. You know what I'm saying? Whatever the hell U prime is, I'm going to put it here and then V plus U, which is this, and then V prime. You know what I'm saying? And then, of course, chain rule. You with me so far? That's just collecting this 1/2 AB as a U, and they're both variables, so there's a chain rule within itself, which I'm going to do now. So then this part, now 1/2 A is U, so U prime 1/2 dA dt B plus U and three-way product rule. I mean, you can do four-way this way too. You just need another parenthesis on this. How about that? You get it? And then you can distribute, don't distribute, whatever. Questions? This is your second semester when you get into E&M and electricity. This is electric circuit, battery and resistor 1 and resistor 2. Most common example of resistor is light bulb. And that resistance is changing, meaning, do you guys know the light switch that dims the light? So if you have invited your study date over to study together, and then you can dim the light a little bit and put some music on and set the mood. You know what I'm saying? Yeah, that kind of light switch. But suppose there are two of them that can be dimmed independently. Okay, and I don't have a time to derive this for you, but this is what your physics teacher will teach you. The total resistance is given by whatever the reason, this formula. Okay, so all we have to do is figure out the rate of this dRt over dt. Okay, let's see how we can do that. Let's rewrite this. So this is RT -1 is equal to R1 -1 plus R2 -1. And they're all variables and they're all changing. Okay, and these two rates are given right here and right here. Okay, so if we take a derivative using the power rule, you with me? And then the RT over dt is equal to, and this thingy becomes this. And the R1 over dt, and this thingy becomes this. And then the R2 over dt. Y'all with me? Say yes.
Yes.
Okay. Now, we multiply negative r squared on both sides. So we have drt over dt is equal to rt squared, canceling the negative sign. So let's rewrite this like this. Algebra. Now let's see which is which. Okay, R1 is 80 ohms. This is omega ohm. And then R2 is 100 ohms. And then this change is given right here, 0.3 ohms per second. And this thing is 0.2 ohms per second. I'm pretty sure you can plug it in without screwing up on a calculator. Then this should give you that kind of number. Good question. Okay, the second example turns out to be algebra nightmare. Okay, I did not anticipate this when I wrote this problem, but the setup is kind of nice, so we'll do it. So I'll give you a picture. Say we have coordinate system like this, and say we have a line, something like that. I'm going to put the line in red ink. Okay, equation of this is given by ax plus by plus c. Notice this is in general form. For this formula to work, this needs to be in general form, and we are deriving this formula. Good. Have you seen anything like this before? It shows up on SAT2 time to time. Yeah. Okay. You should really program this thing so your machine will do it. It's easy program, but we'll derive it together, at least as far as we'll at least set it up together. Okay. And then here is a point. X1, Y1. This is coordinate fixed point number will be given by the problem, and this equation ABC will be given by the problem. Now we have to calculate the distance, shortest distance, and shortest distance has to be this one. This is our D. You know what I'm saying? Perpendicular, and you can do it with algebra. You can find the slope of this, which is negative a over b, so slope of this is b over a. Find the intersection, and you can do it that way, but the whole point is to set it up with calculus, which turns out to be horrible. Okay, so let's just draw the line segment from there to anywhere here, right? And then see, it has a degree of freedom, so if I can minimize this length, then that happens to be that one right there is the idea. You get it? So I'm going to call this thing X and Y because it can move around. It has a certain one-dimensional degree of freedom on this line. You with me? So I'm going to call D, capital D, and then distance formula. Oh, by the way, this is not a related rate problem. This is just regular minimization problem as a review. You with me? And then if I can find the minimum value of this, that's got to be my distance, because maximum is definitely infinity, and there's got to be only one critical point. But how, like, take a derivative of that hideous monster with a square root? Square roots are generally very nasty to take a derivative, eh? So here's a clever approach. We'll let, my computer's frozen again. We'll let f of x to be that inside thingy. Okay, and remember, this is really multivariable function x and y, but then y is a function of x, so I can just write it like this. And remember, y is a function of x given by this. Okay, Now, if I can minimize this, then I can minimize that, right? If all I have to do is find the minimum of f of x, and then later take a square root. You get it? That way we can avoid this horrible chain rule. Turns out to be the same. This is a clever setup. So, shall we take a derivative or shall we plug it in? Which way do you want to do it first? We can take a derivative right now. Yeah, let's take a derivative right now, right? So if I take a derivative, this thing becomes 2 times x minus x1, and then dx over dx, which doesn't exist. That, okay, plus 2 times y minus y1, and then this one has a chain rule, dy over dx. You get it? Now, what are these things, right? Okay, my y over here, we can get y from here, negative a over b x minus c over a. Good? Too much algebra? Okay, I hope not. And then I also can get dA over dx then, eh? Plug this thingy in here and plug this thingy in here. So what we end up getting is 2x minus x1. See, everything turns out to be systems of equation. It's a systems of equation when we set this to 0 between this thingy and this thingy. 2 times now is negative a over b x minus c over b minus y1, and then times negative a over b. And set that to 0. And it's a nice setup, except I didn't realize what kind of algebra nightmare we are looking at. So I'll take out the fully cooked turkey and just show you what happened. Huh? I cannot bring. This is so weird. Okay. Okay. You can see this, right? We are right here. Simplify and set it equal to 0, and let's see how much algebra is required to actually solve this. Plug it back, and that is the y value. Plug it back into the function. And then you end up with this, and take a square root. Then it gives you this thing, huh? Okay, a few years ago, I set it up, and then I usually give up around here. And then I said, whoever can do this first and email me, write it out very neatly and email me, gets the 10 points of extra credit, right? And I said that during third period, first come, first, like only one, the first one. And then somebody emailed me at the beginning of lunch. So she never paid attention to whatever's going on in her fourth period and did this and somehow scanned it and emailed it to me. Like, dang, children will do anything for extra credit. And now you see why I don't want to put this kind of problem on the test, right? However, the setup is still very valuable. If we have some nicer function, then we can set it up and set it equal to 0 and totally find that coordinate right there. You know what I'm saying? Now, using vectors from your pre-calc knowledge, we can still do this much faster. You want to do it? You want me to do it? Or it's not on the test, but you want me to do it or not do it? Your choice.
Okay, do it.
Yeah, let's do it, right? Okay. So I'm going to have a similar setup. This part is just a review of pre-calc, not on your test, okay? Okay, and then I'm going to throw a line, say like this. And as before, I'm going to put that in red. So equation of this is a x plus by plus c is equal to 0. And I'm given a point here, x1 and y1. Okay. Okay, now I am going to draw a vector from here going like that. Okay. Now somebody give me a name for this. Oh, and this point, like before, I'm going to call it x and y. It has a degree of freedom. Now this vector, I'm going to call it vector r. This vector right here. Somebody give me what this vector r is. Would that be this? You can create vector from any two coordinate points by just subtracting those coordinates, right? You remember forgetting this? Okay. Now I need a, do you remember component and projections? Yeah, okay. First of all, I'm gonna need a vector direction of this thingy. Do you remember V vector kind of thing? Okay, I'm gonna draw somewhere here, and we don't know where that is, but let's conveniently, let's draw it right here. Or this V. My computer's frozen again. V, okay. You know, the directional vector kind of thing, right? Knowing the slope of this thingy is negative A over B, right? Right? Does that tell you that this vector, as when x moves by B, y moves by negative A? Do you see that is the directional vector of that line? Slope, x movement, y movement. You buy this? Okay, then we can create a perpendicular vector to this. And I'm going to draw it here because vectors can be placed anywhere. Let's say that's like right there. Okay, I'm going to call this vector n. Somebody give me what vector n looks like. It is perpendicular to this thingy. Do you agree this is a comma b? Because when we take a dot product of the two, it's supposed to be 0. Say yes. Okay, I'm going to call this angle theta. So my distance right here, this is d. Good. Perpendicular distance. So d needs to be r cosine theta, absolute value, just in case it's negative. You with me? Too much trick? This is just right triangle trick. Who's lost? Okay, but let's write it like this. N magnitude, r magnitude, cosine theta over n magnitude. Is that the same thing? Because n will cancel and get. But look at this, n a b cosine theta. Does it remind you of something that you know? Is that what we call dot product? You with me? You with me? Okay, let's start these things because we got, so here's n and here's r. So let's start it. So we have a x minus x1 plus b y minus y1 over, what's the magnitude of this n? Of course this, right? Pythagorean theorem. distance formula thingy. First, so good? Oh, now it's all downhill from here. So what we have is AX plus minus AX1 plus BY minus BY1. So first, so good? Close parenthesis, close absolute value. Still with me? Still with me? Somebody tell me what this thing is. Oh, somebody tell me what this thing is. AX plus BY from here. Do you see that AX plus BY is equal to negative? So substitute that in. So we have negative C minus AX1 minus BY1 over square root of A squared plus B squared A. Absolute value takes all of it to be positive and it's the same thing. Distance formula from point to a line. How about that, huh?